now that you've actually got a go live, no video, oh, here we go. 3, 2, 1, live. Right, okay, sorry, I missed pressing the go live button. Okay, so none of you saw what I was actually just doing then. Yeah, it was just okay. Now, okay. So what we're doing is we're looking at. I was planning on looking at code reviews, and what I'd just done is added an issue for it to the lecture stream. Now, I can talk about some other things, and one of the things that we were going to talk about was smart commits, and actually linking your commit messages to issues. And so what we can do is I can show you me adding some content using a smart commit, and then we can talk about code reviews, and I can go over some code and talk about some of that feeling of what's ugly code, or as one of the links suggest, smelly code that's just not great. But before we start, seeing the cat decided to come and keep me company, I thought I'd just start with a little black kitty cat. There we go. Yes, that's the start of the video. We all like cats. Okay. And if you're allergic to cats, at least you don't have to smell it. Okay, so talking about good and bad code and code reviews is what we're going to do today. Now, as I said, I'm actually wanting all of you guys to use some form of smart commits. So the smart commits here, and so in here, and I'll just make this slightly larger. Over in issues, what I had just done is I had just gone and created a new issue. So if we have a look down here, there's issue code reviews, which, as you see, updated 3 minutes ago. So in this code review, you'll see that there are, this is me changing its milestone, and then I added it to the lectures because it's going to be a lecture, and I gave it a weight. And here I did a mentioned in commit 96 or 97D. Now this commit came in, and the commit message contained #12 adding code review topic update schedule. Now that's quite useful, because what I've done is I've now connected that individual commit message with an issue, which means as you just saw, I can go to the issue that changed it. I can also go to the file and say, okay, so what changed? Oh, that's what changed. Simon added that line number 7 to the code. I can also go, well, you know, I'm interested in what else has happened to that code. So if I go to the project, you'll see that I'll also be able to go to the schedule, click on the schedule, and we have, it used to be called annotate, but then because when people submit bad code to your repo, you want to blame them. So we go up to the blame button in the top here. We hit blame on this file, and now the file divides in two, and you get to see, in this case me, when I committed the different parts of this file. Right? And this is the only one with an actual smart commit, this #12. The others I have just been editing directly online and just hit commit without doing it in a more professional way. Now, part of the reason for that is this isn't code, this is merely the wiki documentation, so some of the restrictions on saying, oh, who broke the code, I mean, it's just a wiki, it's not going to destroy anything else, so generally you don't have as much overhead around that as you might for other parts of the code. Okay, so what we're going to talk about today is code reviews, as I said, schedule. So I've got a code review Markdown document for you guys to look at. So I'll bring it up here, but you can also go onto the site and start looking at it. And that starts just with kind of a simple overview of what code reviews are, because basically about a third to a half of this course is going to be us doing code reviews on your code and potentially me reviewing some of my code to get you used to this idea of giving and receiving feedback, right? Now, once we get to that stage, I'm going to have to get you guys to have microphones, and that's where we might need assistance from Marius or a tutor to make sure there's a microphone in the room so that you are able to talk through your code with me, and I can ask you questions, and we can have that dialogue around code reviews. This kind of push system is okay for more lecture style content, but isn't great for code reviews where you're having to give me feedback. Now, as I said, there are a couple of links at the start here. So this first link is to the ISO standard. Now, for professional development, we have professional organizations. So the International Standards Organization, ISO, is one of those professional bodies, and they set up a set of rules or a set of standards for how things should be done. And because code reviews are an important part of development, they've set up standards for code reviews. They've also set up standards for developing health software or infrastructure software, which also rely on their other standards for code reviews. So if you want the kind of core professional system, this gives you the generalized process and purpose, right? So this is software engineering standards, right? So this is the scope narrative. So if you want, you can see here it talks about the types of reviewing. So if we make this a bit bigger, so again we're talking about the international standards on doing code reviews, and I can't. Okay, if I make it that big, you won't be able to see much. Right. So here they talk about why it's important, the scope, and then some of the terms like ad hoc reviewing, unstructured independent reviews, an author check, you check it, a buddy check. I mean, this is an international standard, they use the word buddy. Are Americans, you might have to let that go. Checklist-based reviewing, formal reviewing, informal group reviews, inspections, issues. So all of these are the different types of terms that you might see in a reviewing process when you're talking code reviews. So you can go here, and if you see a phrase you don't understand, they give you a good definition of what it might be, and also the standard for what that might be. And as you see, they keep going down, and there's lots of technical reviews, walkthroughs, work projects. So so that's that scope. So if we go so in these later ones here, the conformant, you'll see only information sections of standards are publicly available. Review all the content. You'll need to purchase the standard with the buy button. Because they're Americans, they want you to pay for the standard. So unfortunately, unless you're willing to, so unless you want a personal copy, some of these standards are actually purchased by the library. I haven't checked if this particular one is, but one of the things you can do is you can go to the BibTeX search for the library and actually see if you can find the standard. Now, we are not going to use this terminology in this standard. I'm just pointing you to say that is where a standard is. They will make you pay for it. Now, if we have a look at, so I'll close that one off. If we have a look, there are companies who specialize in code reviews. Now that companies are so development houses are so large, there are specialists to help them with particular parts of their process. Should commits be imperative and capitalized? ID. Right. Right. So I've just had a question in the Discord that's asking me about should you, like, what is the standard around capitalization and statements in commit messages? Actually, all of that is a standard within your group. Once your group sets a standard, you have to follow the standard of that group, right? Now, this is particularly tricky when you're working across multiple groups and they each have different coding standards and commit message standards, and you then have to try and remember which project you're on, which is also why we suggest, rather than kind of trying to do 3 or 4 different projects within a day, you kind of try and allocate a whole day to one type of project, so you can get your head into that kind of commenting, the kind of text, the content of the code, and the commit message styles and the documentation styles. So all of those should be consistent between the developers and the group. So, and whatever they choose that's what you do. So I was being relatively lazy and just put my #12 at the front. Okay, so here we have a company called SmartBear that gives you some ideas for what some of the best practices are for code reviews, and you see here we can go through and discuss some of these, but you can also read them yourselves, but they are relatively simple rules to try and help people become better reviewers of other people's code. So review less than 400 lines of code at a time. Don't go for more than an hour. Take your time, so 500 lines of code per hour, 400 lines in a session, and therefore basically don't code review for more than an hour. So we have these 2-hour sessions, so I wouldn't spend the whole time reviewing one person's code. That would be too long. The cat's making noise. Set goals and capture metrics. So if we're going to actually review code and we're going to try and achieve something by the review, rather than just, is the code okay, which is perfectly reasonable review, like, do I understand your code? If I'm going to make the code faster, or am I trying to refactor it, or am I, what are we trying to get through? And if I can measure that, then I can hopefully improve my review process. Also should annotate code before they review it. So if we're going to do a code review, one of the things that I'm going to ask you to do before you show off your code is to add a small number of comments so that we can focus on the parts of the code which you mostly want reviewed, and to help us understand what the code is, so that we can review it as quickly as possible. We've got limited time, we're all working here together, so a little bit of annotation on the code itself, commenting, is quite useful. Now, I'm going to make some comments about commenting. This is a professional programming course, not a learning to program course, and so I do not expect you to write large numbers of comments. In fact, often professionals say there should be almost no comments in code. Header comments fine, saying who wrote the file, so you know who to go and see, but a lot of that now is handled by the commit messages, and so you don't actually need to document in the code itself. The Git repository that the code is in tells you the author of the code. So a lot of the things that we used to do, where the code itself was its own documentation, we now move over into the Git repo that is the code documents it. So a lot of those kind of function headers and all that sort of stuff, some of that, why is this function here? Well, that should be in an issue. That issue should be in the issue tracker, and I should have a smart commit on this function. And so when I go to this function and I do blame, I can see the issue that is the reason this function is here. Right? So I can click and immediately click through and see the full justification and the discussion around the point of that function. So rather than trying to write it in a big header above, or a big comment section above each function, I now actually do that in the project documentation as part of the Git repo, not in the code itself. So we used to have to do that, now we don't. We also, as you might have noticed in your first couple of years of programming, there were unnecessary comments in code that you were given. Comments about, count, well, int count. Count counts the number of items. And it's kind of, yes, I can see because it's called count, and it's an integer, so it'll be a number. So those sort of comments, complete waste of time. No professional would do them. Get rid of those comments in professional code. What you want to comment is things that are really, really challenging, or things where you've optimized things, and so the optimized code is the code that you want to comment. But here, when I say annotate your code, that's where you might add a bit of description of what's coming in, what's going out, just to help us review it. Using checklists can be quite useful. Part of the reason to use checklists is that often you get so focused on one particular problem with code that you forget all the other things you should be checking. So if you can think of, what are the things that you need to do, write those down first, and then when you're reviewing someone's code, you go through that checklist. And there are, as it says here, lots of examples of checklists. Do I think you should learn? So I've had a question from Discord. Do I think you should learn Doxygen and other documenting tools? I really like Doxygen. Personally, I think it's a really nice package. Maybe I'm a little biased because I quite like documentation in LaTeX, or writing my large documents and thesis in LaTeX. So I like that Doxygen will generate LaTeX documentation from your code. I enjoyed that. But that's just a personal bias. It's not something you need to do. Learning to comment and code and write comments in Doxygen, yes, it can be very useful. It's an interesting thing to try. If your company that you're going to work for uses Doxygen, great. Do your Doxygen comments. They obviously are creating documentation within the code, right? And generating actual documentation and projects from the code itself. Now that's different to comments, because comments, and some of the things you'll see in comments, were justification for why a piece of code is where it is, rather than Doxygen, which is supposed to be comments about how to use the code. So those are serving different purposes, and so the comments about issues and the reason for making decisions should be in an issue in your code repo. If you're talking about Doxygen comments and you're going to release a piece of software with fully documented code for other people to develop with, then yes, you do want something like Doxygen, so you can hand them those API references and all that work more easily. Again, it's relatively simple to use Doxygen. You'll learn it in a day, so it's not that it's a specifically challenging thing to learn to do. Okay, so establish a process for fixing defects found. Okay, so when I find problems with your code, and if you find problems with each other's code, one process is you suddenly stop and you try and fix it right away. That's not great, because everybody's waiting while you try and tinker with your code. So what you do is you have identified that problem, right, I'll put that on my issues within my repo to go and fix. And then you have a deadline for when you'll fix it, so we can come back and have another look at it, right? So that's important. Fostering a positive code review culture. That's one of the things I'm going to try and do today. But also one of the things that we do as a community. One of the nice things, you guys are not competing against each other in this course. It's not like you've got one assignment and you're all trying to do that. You each have your own projects. You're each trying to create the best code you can. If you help each other, that's great. It's not going to disadvantage one of you if the other people are also able to code well, right? So this can be much more collaborative. So I've had another follow-up question on JavaDoc. You can actually run Doxygen over JavaDoc code, and it will generate documentation for you as well. So both JavaDoc and Doxygen style commenting are just a formal way of writing comments, such that a third-party program can run over your code and generate that documentation. Now, Visual Studio, and I believe, and if you guys want to talk more about JavaDoc and Doxygen, I believe Visual Studio and BlueJ and some of the other Java IDEs understand Java documentation. So if you write Java documentation, when you do mouse overs, it gives you that additional information. So for example, with Visual Studio, if you give your function comment in the right way in a Java doc or in a Doxygen format, Visual Studio will allow you to, when you go and have a look at that function, it won't just pop up the function parameters, it will also pop up the comment that you made about that function with the additional information. So this I will have to Google. Now, okay, this is me live Googling my answer to work out if I was actually telling you the truth, which is Visual Studio Doxygen real-time comments. Okay, so what I'm looking for is okay, so there's a Doxygen generator in Visual Studio Marketplace, but if I do Visual Studio comments IntelliSense, so the IntelliSense system is the system that oh, if you spell it correctly, the Intelligent Sense system is a system that Visual Studio uses like that, to go through and work out, is this a valid function? What are the parameters of the function? So as you type, it says, oh, these are the things you could be matching. How to have comments and intelligence for a function in Visual Studio. That's what I was looking for. And so if I go and look at that, so in C#, you've got, toString, and you want some sort of comment, and the answer is they give you recommended for tags for documentation comments in C# programming. So in C# they go // and so here, as you can see, and I believe this is correct, you need to use XML comments, basically follow the syntax vaguely described in Solmead. So here, if you do this summary, copy, and I'll just bring up my Visual Studio. Now I have some various bits of bad code in here. So this isn't C#, this is C++. And here you see this. Oh, actually, yes. No, this is sorry. This is terrible code. We'll get back to that. I was going to actually run a different project that has some of my code rather than this code in Norwegian. Some of you might have seen this code before or not. We'll get back to that. But if I open a project, the vector list project is the one that I've just opened, and that's open. Pretty sure I said, yeah. So this is testing vectors, and here you could have a long test vector, and if I go like that, I can add that comment and go test the vector implementation. So that would say test the vector implementation. Now, because I've added these comments and I've given it XML style summary, Visual Studio knows that that's a comment. And so down here where I actually test vector, oh, that's vector R, I'm looking for just straight vector. Where is vector? Test vector. Aha! So maybe you can't see that, but I'll just see if I can make that up. Let's see. Well, yeah, okay. I will have to find my magnifying glass. Oh, I don't know if my magnifying glass works here, but what I've just been able to do is when I mouse over that, very small on my screen here, it now gives you the function description, and in the IntelliSense, I test the vector implementation. So this is now allowing Visual Studio to add comments to my mouse over. Now, if we look at Java doc style, and we go to Java doc style in Visual Studio. Now, Java doc, of course, isn't the style you'd use with C++. There are different
we can currently just see an XML example rather than what you're showing us.
Aha, right. Okay, so what I needed to do, thank you for actually interrupting me. Right, yes. I needed to hide that and go there. Aha. Sorry, I'm still kind of, yeah. So here in this example, what I had done is added what I copied from the web page. So / XML style summary / the words / summary, and then down here where I actually used that function, hopefully you guys can see this now, here is the test vector, and very small, if you zoom in quite close, you can see it now says a long test vector and runs, and it does test the vector implementation. Right, so that comment has now been added to Visual Studio's IntelliSense. Yeah, so that's an example. Aha! Thank you for someone interrupting me. So sorry that I was off script for a while there. Now, okay, so that is one of the styles of comments. If you look at Doxygen Comments, and if I turn that back on, if we go to the Doxygen Comments, you can see I don't think that Visual Studio natively understands Doxygen, but you might be able to with the Doxygen documentation generator in Visual Studio. In the marketplace, you may be able to do a plugin that does it, and you can improve your IntelliSense so it might be able to do Doxygen. And so there we go. In Stack Overflow, great place to look for this stuff. Right. So nobody's answered that one, which is so Visual Studio will recognize the XML documentation, right, for tooltips, which is what I just showed you. And is there a way of getting the functionality for the Doxygen comments? And the answer is, well, apparently not, unless you're willing to go and get this as a plugin. So there is a Doxygen plugin for Visual Studio. You can get it for free, and then your, I believe, IntelliSense will then work with Doxygen style comments. So yeah, so if you want to learn Doxygen, you want to use Doxygen, you're using Visual Studio, then that's probably a really nice way of doing that. Okay. So we can't see the small tooltip, but yeah, I'm glad you understand. You get it when you do that yourself. Yes, it will be it will work. It's just that it's hard to see on my screen. And yeah, I'll just try one more thing to see if I can make it go large, and then I shall pause that. So if I go into and window, and I just have to remember where my text tools are. I think it's under options, and I can make my text. Nope. No. I'll text editor. If I got the it doesn't have the font size there. I can change this to 200, which makes that larger. Let's see, does that make that larger? Not really. No, it doesn't make. So it makes the code larger, but it doesn't make the tooltip larger. I would have to kind of zoom in, and we can do that later. And we'll go through and review some of this code anyway, so I will be using that window later. Okay, so back on code reviews. So commenting, annotating some of your code review is very useful. And when we're going to review code, I haven't annotated some of this code. Well, it's got some annotations in it, but they're not great. And so we'll look at that as well. embrace the subconscious implications of peer review. A lot of you will be embarrassed to share your code because you feel your code's not ready yet and it's not good enough, and it's kind of but I don't want to show my code, and people will see it and they'll know that I'm not good at programming. That's something that's called Impostor Syndrome. It's a clinical condition. Lots of programmers have it. Lots of people have it, where they don't think they're good enough at their job. You have to get used to this idea that I write code and other people will look at it. Because again, as a professional, you are writing to communicate with other programmers, and you have to be prepared for them to read what you've written. And so this idea that code review becomes a normal part of us developing code means that actually even when you're writing code, you start thinking, this is going to be seen by other people, so I better do it properly. So that's one of those kind of implicit code review keeps you thinking, yes, that's right, other people will have to read this too. As it says, practice lightweight code reviews. Full formal code reviews where you've got your CTO come in and the boss come in and they're grumpy at you for getting it wrong. That's high pressure. Review each other's code. Just have a look at each other's code and give each other a hand. It really helps. And this is within your group. It doesn't have to be formal, it doesn't have to be heavyweight. Just look at each other's code and help each other. So those were SmartBear has those recommendations. It also sells tools and sells software so that you can try and get better at code reviews. We've had a question about group grade versus individual grade for the course, because there was a question earlier in the course around is a letter grade or a pass-fail. We currently still have a letter grade, partly because I wanted to be able to say, oh my god, you're an amazing programmer. Yeah, your thesis, your writing's not great, so yeah, you got your C as your thesis, but you're an A programmer, right? So I wanted to be able to say you're an A programmer rather than just say, oh yeah, you can code, right? So that's why we have letter grades. I do it as an individual. Even though your work is in groups, I expect you to individually reflect on your contribution to those groups. I will be assessing you as individuals contributing to those groups, right? So yes, it is individual grades, not group grades. And again, that's partly because I want to be able to give recommendations for you as individual programmers, having read and reviewed the approach you take to programming, and kind of have had some discussions with you. So that's so that's why it's individual, and that's why it's letter grades. I do expect you to work together. I expect you to work in teams, and I expect you to do code reviews with each other. There isn't an explicit part of the grade attached to doing these code reviews. It's not like I'm saying, 4% of the grade is for doing code reviews. Did you do a code review? Yes, give you 4%. I want to see what you contribute, and I want to see also when you document code and talk about refactoring, and that's one of the things that's required. Is to document your process. I want to see documentation around refactoring, and that's actually easiest to do when you do a code review. You get a whole bunch of feedback and you refactor, right? So we will actually be using what you get out of refactoring as part of the assessment, but I'm not going to put a strict number on it. Okay. So if we go back to the code review page, that Markdown that I wrote. One of the really nice and now getting slightly old books/papers on code reviews are these refactoring. And so this is a PDF of a book that was written. It was written in the early days of Java, as you can see, 2002. So this was 17 years old. So incredibly old book, but the principles of refactoring, unlike coding standards, most of the ideas here are still relevant, right? So sometimes going and reading really old books is okay. If you're looking at it for great examples of modern coding, throw it out. It's useless, right? It doesn't help you with modern coding standards. It helps you with kind of some of the way we used to do things. So, but it's a 330 page book, right? So it's quite a long resource. There's a link there to it. It's openly available. So what I thought I'd do is talk about some of the reasons why we do code reviews, and quickly go through that because it's written down here. So you can also go through it yourself, hopefully. The book is old enough to drink and drive, and probably make dirty jokes as well. Yes, it is certainly an old book. However, I've got a wee bit of summary here that I've got some of my key points from the early parts of the book in here. And I'll open also some discussion on code. And so the idea is I'm going to do that for a wee bit, and then we're going to look at some actual code, and I will start talking about some good and bad bits, and what you might do to assess code, right? Now, I've got 3 bits of code that we're going to look at tonight. I have a vector class which was done as a test for the second year algorithms course in Trondheim, where they were suggesting that a linked list implementation was more efficient than a vector implementation for the snake game. He gave an example of the code. I then actually took that example of code, put it in the profiler, ran it to see if it actually was more efficient, and it wasn't. So we can look at that code, and we can actually refact that code and start looking at where that code is poor code and what's poor about it. I have an example of the algorithm course in Jørvik from Frode, from one of his example zip files, just to have a look at some of that code. And if you have a suggestion of code that you would like me to review from him, we can put it up and I can start going through it as well. So we can, if you send me a link to the code that you'd like to review, we can do that. And I also have my thesis code from when I was 22. So when I was your age, I started on some of my code that would end up being my thesis, and some of that is truly awful code that part of me is very embarrassed about. And the other part of me is, well, I have to show you that I was a bad programmer when I was 22, to show you that, yes, you need to be able to be open to criticism and be able to point at the code that you've written previously and go, wow, I did that badly, and now I do this, this, and this. Okay, I see we now have Frode memes. Lovely. Okay, so the next bit is I'm going to talk about some of the things to think about when we do code reviews. One of the phrases that how many of you have heard of technical debt? I'll put that in the Discord. And how many of you have heard of technical debt as a phrase? So, luckily you can see what it is here to some extent. The idea of technical debt is that when you're developing code, you don't always have time to get it right the first time. Right? So you're kind of a bit stressed, you're cobbling things together. Or you're trying something new that you don't already know how to do. So, and this will happen to you a lot when you're first learning a program, that you'll start coding something without knowing what you're trying, like exactly how it works. So what you do is what's happening is we call that technical debt. Every time you add complexity or code that is not good into the code base, you're adding what we call debt, and that and that debt has to be repaid at some point. Now, one is you get it when you're learning. There's another that happens in a very short duration, which is the boss comes in and say, right, I need that function. I need to be able to see that function on Monday, and so you just hack shit together until it works. And then that while you're doing that, you're adding a lot of technical debt because you're adding a lot of magic numbers buried in the code. You are just getting whatever works. You just do, I'll do a for loop through everything. I know I only have to own one of them, but I'll just do a for loop and say if it equals this, then do this, right? I won't worry about how I got that or if it's inefficient or all of the kind of, is that the right way of doing it? No, just get it done, get it out, get it working, and I'll fix it later. That fixing it later is that debt. And the long duration chronic version of this is where you're just developing code, but you're always slightly stressed and you never get round to going back. Now, some of you will have this with your thesis, hopefully not already, but you will put some stuff in your thesis which you will think to yourself, oh yeah, but I'll go back and I'll fix that later. And then you'll just move on, you'll start doing other bits of the thesis. And you just never get round to going back and fixing it, right? And so there's this debt in the project. You have the same when you're writing your documentation. You go, oh yeah, there's the abstract. I'll just leave that blank. And oh yeah, introduction, write something clever about the introduction. And now that's a debt. That's something you have to fill in. So certainly you can, borrow money to buy a house, so you get debt. You then have to pay it back before you complete the thesis. Now, so the debt is the gap between good code and the code you currently have in your project. There are ways to prevent people from doing some of the worst aspects of technical debt. One of them is called linting. I don't know, have any of you heard of linting? Spelled linting. We're a Google-enabled world. So if I go linting, it'll take you to the wiki documentation. Okay, so a roller. So lint in fabrics is the idea that you have little bits of fluff that gets in the way of stuff, and so a linter is something linting is removing the lint. Removing that kind of chaff, so the undesirable bits of fibre or fluff. So what you have is that's a process where you have tools which statically check. So if you look at lint software, then in here you'll find that we have various tools listed, and references, and the idea is that for some things, you can write valid code which is still not good code, or that doesn't conform to the standard that you want it to. One of the old ones that we used to do, and very few of you will have seen this potentially, because I don't think many places actually do this, but there was a recommendation that if you did, and I'll come down here and just put an example in here. So if you do, if A equals that one, if A equals 10, then print if D, comma A, and boom, and A equals 10. Right, now hopefully all of you will notice what's going on here and what's wrong with that line. Are any of you willing to suggest what's wrong with that line in the Discord? Do we have a Discord person who's willing to say, that's an assignment, that's not great, it will do a terrible, terrible job, because it will, and if I go in here and I change my number of runs down to something more manageable, and I think I've written this terribly badly, so it has the word run in here somewhere, that might be a parameter. So I need to give it fewer runs, because at the moment this code is actually simulating a snake game to some extent, and running thousands of tests, and as it's pushing back thousands of rectangles and doing a whole bunch of operations. Now if I'm correct, let's see, I can run, include timedruns.h. So in my header file, timedruns.h, here, instead of using a configuration file, I've used a header file. Right? This is one way of doing it. This isn't necessarily the nicest way of doing this. Actually using a configuration file, a .config, is usually better. But here I've got a timed runs, I've got a header file, 20 runs. So if I reduce this to 1 run, and I reduce it to, instead of simulating 1,000,000 moves of a snake game, let's simulate 1,000. The maximum length of the snake is 200. So now when I run this, I should get a yep, so it runs, it does the check. It doesn't say very much, but the interesting thing here is it says the number 10, which was that piece of code that I put at the end of this previous file, which is, you know, if a equals 10, print a. This if I can set a to 1, and of course, because this is an assignment in C++, this will work and will give me a terrible number 10 there, where it actually says it was number 10, because of course what I've done is I've put an assignment operator in here. So one of the things that a linter could do, and one of the things that it used to do, is that it would actually take that and you'd say you never do that, you always do 10 equals a. Basically, because an equal or a test, right? Because a test you can do it on either direction. I can say a equals 10 or 10 equals a, both for a test, those are both valid. But for an assignment, you can, if you go 10 is equivalent to a, that's fine. But if you do 10 equals a, it's going to go, wait a minute, freaky out, I can't do that, right? Because you can't, because 10 is a const and you can't assign to a const. So it's a primitive, it's a numeric value, so you can't assign to a numeric value because it's a constant int, right? So expression cannot be modified as an L value, which is a left-hand value. So one thing that some companies did is they say, oh, you should always put the variable on the right-hand side. You can make a linter check that. It can check all of these and say, ah, look, you've got them around the wrong way. I won't accept that code until you put it around the right way. That's very annoying. It does enforce specific coding styles on people. And to some extent, that's an idea to try and decrease the amount of technical debt, because if you can have the linter run over it and say, no, that's not acceptable, you can't put that code in. It says you can't sort of borrow, you can't create bad code in that way. Of course, this is this is a terrible way, and of course, if I was doing this properly, I'd do that, and then I'd say, well, actually, no, I never do that. I always put brackets around everything, because I never rely on the fact that it just happens to not have a have an extra line finished, so I'd always do it that way. And, you know, here, it didn't pick it up, but other systems like your linter would pick up if you made those errors. And some static checkers will say, are you sure that's really what you want, is an assignment inside an if statement? Terrible thing to do. Right, so if I go back, folks, if I can go back to that and go back there. Right. So linting, pre-commit hooks. The idea of some of those is to try and decrease the amount of debt by slowing down people's ability to put code in that's not good code already. That can be counterproductive, particularly if you've got a deadline. Sometimes you want to be able to get into a bit of debt. Just like, you know, you need to buy a hot water cylinder. You need the cylinder now, otherwise you're going to have cold showers for 3 months. Yes, you'll get around to paying it off, but you need warm showers now. So yeah, sometimes it's useful to get into debt so you can achieve you can achieve your actual goals. Okay. Yes. So I'm glad you people worked out a horrible name. Yes, it was. Yes. And equals and yes. I'm glad some of you yes, and people have started pointing out other things that was wrong with it. Yes, you got the double equals, the magic number, it is a 10. It'll always be true. Yes, that's true. That's the equals and Z. The Untitled Operator is not an equal operator. Yep. A horrible name. A is a horrible name. Yes, it's a terrible, terrible job. So, but that code compiled, and this is one of the challenges of writing good code, is actually also writing code that is clear as to why it is doing what it's doing. That code has no purpose. I didn't give it any purpose, so there were lots of things wrong with that code, and we'll get to that very soon. So I'll just give you a quick overview of the sort of things we do. So the rhythm of refactoring generally is that we do lots and lots of refactoring, and we use code reviews to refactor our code, right? So we're doing these code reviews. You look for the error issues, as I went through, you know, a checklist of having a checklist and having a positive review. What you use it for is refactoring, right? So often when you do a code review and you find problems with the code, you then have to refactor your code. And so from that, the book there, this idea of refactoring, regression testing. So if you've got code that works and someone's doing a code review, then they're not doing a code review to help you get the code to work. They're doing a code review to help you improve the quality of the code that already works. And so to make sure it already works, what you do is you have a regression test, which is you have a set input, and you run your program over that input, and it gives you a known output. You then save that, and then when you start changing things with your code and fixing it to make it more understandable, you run the same input through it to make sure you get the same output, so that you haven't changed the functionality of the code, right? So code reviews aren't just about finding bugs and fixing your code and making it work. They're about making your code better and yet still do the same actual task. Some of the reasons to do code reviews and to do refactoring is to improve the design of code. When you get other people to look at your code, when you rethink about what your code does, the second time you do something, you generally do it better than the first time. It helps you understand your code by having other people look at it and you having to explain it. We sometimes call that the cat method of debugging, is where you try and explain your code to your cat, which generally doesn't care. But in your having to verbalize it, because it uses a different part of your brain to turn the programming concepts into words, it makes your brain access the code in a different way. And that different perspective, even if it's just a linear verbal perspective, sometimes will help you find what's wrong with your code. So sometimes it's just the act of reviewing it means that you don't have to do it, the rubber duck method. You don't have to do it. You don't have to go to someone who actually understands your code. You're the one in your own description that fixes your code. So rubber ducky is the other method. So finding is another name for the same method. So it can help you find bugs. So even if your code's working and you go to a code review, some people will look at your code and they'll find bugs, because as they're trying to work out how the code works, they'll see something is, did you intend to do this? And you'll go, no, I didn't notice that, right? And that would have been a bug that you didn't pick up. And we're all heading, interestingly, for a 2038 bug that's going to be the Unix integer overflow, which will be an interesting bug. But yes, like the did you intend something, review things to find out if you did. When to refactor, basically, if you're using a piece of code a third time, you should clean it up and make it a good piece of code. One of the other things I wanted to talk about is the sense of ugliness. And some people will call it smell. Some people will call it bad or yuck code. It's where you get the sense that code is pretty or ugly. Now, the more code you look at, the better your appreciation of good code becomes. So this is a bit like drinking wine, right? You don't get a good taste for a particular wine you like by drinking the same wine all the time, right? What you do is you try lots of different types of wines. You read different programs. You look at different languages. You study them, and that makes you better at understanding what makes a a piece of code good or bad. Some things you should watch out for ugly code is if your functions are massively long, that's probably a problem. If you have really big classes, that's a problem. Parameter list is a really interesting one. If you have lots of parameters, it's kind of gone through phases. So initially, you did short parameters so that the functions were understandable, and you used a lot of globals, right? Because you knew, there's only going to be one of these, so everybody needs access to it. So we used to use globals. That went out of favor and said, oh no, the globals are terrible, never use globals. And so people put everything into the procedure call, lots and lots of parameters in each function. And then the OO people said, oh, that's impossible to understand. What we'll do is we'll just put the data in an object. You'll make a small call and just enough for the object to know which bits of its internal data to use, and then we'll just use internal data. That's now started to go out of fashion as well, because there are people who say, well, that requires you to understand what's happening inside the object to know what the minimum number of parameters should be to make that object do the right thing. And so what we should be doing is moving to somewhere between those two, where we pass in some things and we have out some stuff. And in fact, one of the C++ 11, I've sort of first introduced it, and then 14 and 17 made it better, is that you can return structures from functions, and so you return tuples, which means you no longer have to pass something that you're going to change into a method or a function. Everything you're going to change you have on the left-hand side, and everything that doesn't change is on the right-hand side. And so that means I get to do A, comma B, comma C, or X, comma Y, comma Z equals position of asteroid. Right? So I can, after this is an asteroid, instead of having to pass in a structure that gets updated, I actually have an XYZ that will be updated. And that gives you a lot of power to change the way you think about how you write functions, which then changes your parameter list length. So advice around things like that, what might have been ugly in the past, like flares, became popular, then became ugly, and then become popular again. So some of these things are preferential stuff, which happens to do with kind of the environment you're in. I have some issues with code which uses very tiny differences to change what it does. So, for example, the ternary operators here, with just the greater than or less than sign telling you what's going on. I much prefer this to have inside it things like actually name this function. So I've got a function name that I know what it's trying to do. What is that line of code doing? I've asked the question. I will put the question in the Discord. What do you guys go what that is actually doing? What would you call that function? It's a ternary operator. It has an A equals A less than B question mark B colon A. So it has a less than in it. So what function is it performing? Carl's going to have a guess. This is kind of like a code review. You guys have to guess, and I'm going to see if any of you can get it right. Unfortunately, the YouTube people will have to wait for like 30 seconds before it comes online. And also you can try and guess what the last one does as well, right? As an example function. Now, for me, those are really, really short, and they're horrible because they are too short. So yes, you've told me what it does, Sondra. Excellent, that's fantastic. A is set to B if A is less than B. Otherwise, it's set to A. So what function would you normally call that? It's called, well, it's called clamping, right? It caps. It sets a maximum value. So if you're, for example, you had a maximum health set at 1, you could have B set at 1. Yes, find the largest of A or B. Yeah, so it's the same as, well, yes, it's the same as min of A and B. So if B is static, you return A unless you get to B, and then you return B, right? And so you can actually call this min. Now, if I use min, so much better to actually say that function is called min. Now, with 2 parameters here, that last function, so that one's called min. You could also say if B was static, it would be, cap at the maximum B, because if A is bigger, it will be a minimum of those 2. The last one is actually what you'd normally call clamp. And the clamp function takes a value and gets a limit, right? So you say A runs between, say, 0.0 and 1.0. If you did that, right, so you did clamp A 0 to 1, what you're saying, if it was like that, you might actually say, if you're doing this properly, it would be A equals clamp, and you would say clamp A 0, 0. Those would mean that A now is restricted to be between 0 and 1. Right? Now, you could do it with that ternary operator. I would hate you if I saw that code in the middle of a normal function. Right? Just wandering around and then suddenly that line and then continue. It needs to be called a function. I need to be told what it does, because I do not read that and instantly know that you've got it right. Right? It's also the last one is a bit confusing to read because the double question mark. Yes, the double question mark is awful to put in there, because you have to then understand the groupings that are going on. And yes, auto XYZ process data object, that's exactly what I was talking about before as being a wonderful thing we can now do in C++ 17. You couldn't do in earlier, I think 11 brought in auto for those structures, but I think 17 has actually cleaned it up and made it better so that you can set them up more easily. So this is a line of code that if I see this line of code with a double ternary operator, it's clever, but it's wrong. So don't do that sort of shit. That's the sort of thing where when you see that, you say, no, I do not have the time to mentally put in to understand what that does. Can you find a standard template library function that does it instead? Or you write your own function that does the clamp so that you don't have to have that line of code sitting in your project. Yep, it works for arrays. So one of the last things, a couple other before we go on to have a look at some actual code. Primitive overuse. When you first learned to code, you learned about primitives. You learned about int, and you learned about double, and you learned the primitives of the language, and they're safe and they're easy to use. People massively overuse them, and of course, in the olden days, we only really had primitives. We didn't, data structures were too heavyweight, so everybody was trying to minimize, and so primitives were the minimum you could use. So every bit of storage was critical, so you used primitives. That's why we have a 2038 Unix problem, which is in 2038 the Unix integer counting on its date time format will break. So we don't know what bad things will happen to all the Unix systems in the world at that point. This is far worse than the Y2K problem. Oh, I've got a cat again. So that comes down to you having a feeling of, it's kind of like an int, so I'll just use an int. That's actually not a great way of programming. If you know you have a day, days of the week, use an enum. Create an enum that goes from Monday to Sunday, right? If you want to have a structured type, create structured types. It takes a little bit longer, but it saves a whole bunch of later challenges and problems. So yeah, so we overuse primitives because no, it'll be fine, it will just be an int. Day of the week, that's an int 1 to 7. Problem is, integers are not 1 to 7. Integers can be 8 and 10 and 13 and -5. Unsigned int can't. But using the primitive means that we allow all of those values without having the computer able to say, oh, wait a minute, that's an error. So actually creating structures and using the computer to help us write better code takes a little bit longer at the beginning, but works much better in the end. And speculative generality, you guys will do this a lot. When you're writing your thesis, you'll go along and you go, oh yeah, hey, how about I add some 3D camera movement? And the other people in the group go, no, it's a 2D game. It's only ever going to be a 2D game. We're not going to make it a 3D game. And they go, yeah, but if I just add a few lines of code here, and I can add some like Z components, and then I can have like a full 3D camera, and it's going to no, it's a 2D game. You don't need to generalize your camera machinery to a full 3D environment and write code around splines to get it to go nicely and have an up vector and quaternions. But no, don't generalize. Just get the job done. You'll be tempted to generalize. Engineers are tempted to generalize. So yes, please don't overgeneralize and don't write too many comments. Okay, so that was my quick going through. Took an hour. Going through that page and sort of discussing why I have those things there. I thought for the second part of the discussion, the lecture, I would actually have a look at some code and get you guys to potentially raise your hands in the Discord channel, and sort of discuss some of the reasons why I think code is good or bad. Now, if any of you have a link to any of the code, any code that you would specifically like me to look at and talk about now, we can do that. I do know that we have, let's see, where is it? I'm just hunting for the specific piece of, where did I put that? I think I've hidden it. So that we have Froda's code that we could look at if you want to. We can look at some Visual Studio code. We can look at Visual Studio code. We can look at my thesis code, as I said. So if I just turn off that, we are now looking at code. Okay, so can I have a vote in the Discord of what you would like me to review? So we have Froda. We have vector code, or we have thesis code. So people hopefully can put a hands up next to one of those. Oh, Doom code. I can do that too. I actually do have the main loop from Doom 3 here somewhere. So I can actually go into the game loop Doom 3. I'll just do a quick search for it to see if I can find that. Actually, there are people who have done that particular code review. So yes, there are people who have code reviewed Doom. It is astoundingly terrifying code when you actually have a look at it. And I'll just see if I can find and put up the original code. Right. So yep, if I just go, anyway, well, so one person suggested that. Other people can suggest other things. So Doom code. Right, so there's a bunch of people who are upvoting Froda and a bunch of people Doom code. Let's have a little look at both, right? So what I can do is probably with syntax highlighting is probably going to be the best. So what I'll do is yes, I've seen all that code. Right, yes, there we are. This is the the main loop.
Hey again, the stream died.
Just a sec. Copy. Okay, there we go. Aha, right. So, sorry, I just took a while to copy it over into Visual Studio. Is the stream down, or was it just that it was not? Oh, okay. It's still waiting. It's back. Okay. Sorry, the stream. My machine seems to have not wanted to stream that particular bit, but maybe I was looking at Doom code. So, okay, this is the Win API call for the Doom code. This has been subsequently commented because they were trying to make it a wee bit more understandable. But as you can see, I think if we go through and we have a look at some of the main loop of Doom, so as in win main, the main loop, as you can see here, we have a not too large, but we have the handles to the instances, right? This allows us to connect to the window and render things. It does an instant set physical working memory to 192 shifted right 20 and 1024. Oh, so it shifted left 20. Basically, 20 is a megabyte. So what it's doing is setting physical memory between 192 meg and a gig, right? So 1024. So that's the physical memory. So this is wanting to have up to a gig of RAM, right? But it want 190 meg of RAM. So yeah, so that actually kind of translates to those min and max numbers. And then its console. Since the engine is a multi-threaded and uses mutexes, you need to initialize all those mutexes. So it does a for loop, standard for loop. That's perfectly understandable. Initialize critical sections, an excellent name for a function because very clear what it does, and you passing in the things to initialize. Now in modern C++, that we'd actually move this bit would be over here, and you'd be doing an assignment to it. But you know, this is the way C++ was in the olden days. So here we also have a system thread. While one, oh yuck, 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 yuck. Okay, so yes, this what used to be common. It is a terrible, terrible thing to do, but it is the hacky job that Doom was as a game. While one means this will never stop. Now, of course, it does stop when the game quits, but basically what the game does is it hard crashes out of that loop, right? That's kind of just rude as code, but basically this is the syncing thread. It does a usleep of 16666. That's because it runs at 60 hertz and microsecond sleeps. There's that many microseconds between each frame, and so this is just a heartbeat that sets the async job working each time. Magic number. This is not even a number. It is a true false value, so it shouldn't even be an integer. It's ridiculous. So yeah, both of those are terrible. This is the way that you get something to tick at a 60th of a second. Pthread test cancel. Check if there is cancellation in the main thread and on shutdown. So basically, every tick it goes, hey, main thread, have you shut down? And if main thread no longer responds, then this thread goes, oh, it's time for me to stop then, and just hard crash out of this loop. So that's what that bit of code does. We then have another while one, which again run infinitely, and we have a common frame, which is a function, defined inline craziness. So yeah, so we have a win frame. We define this inline. It has a session frame, which is the game logic, and here I'm game ticks to run. This is an interesting. It's a for loop. It runs through the number of ticks required, and it runs the tick. And if the game frame you go to the game, it then runs a particular frame. So it runs ticks and then it runs frames, and it goes through each one of them, doing a physics update based on the time. Right. So that runs the physics update loop. And here we have the rendering update loop. Right, and so here you go, update the screen, and you do this render begin frame and update. Right, so within each frame you do a physics update and then a rendering update. Right, so that's the code review. If you were to refactor this code, you might, well. Yeah, it's relatively short. I personally hate this style of while forever, but if a company has that style, a for loop running through game ticks, that's acceptable. It does this for loop where it goes through each entity, and each entity is then told to do a physics update. That's a little bit, I know. Now what you'd do is you'd have a physics engine, and you'd just tell the engine update all of the locations of the objects, so it would be quite a different look about it. Yes. It's not too bad. It's a little bit hacky, but it is relatively clear in what it's doing. So the async thread is relatively clear on what it's doing. And this really could have been set as a value, to be honest. You have to know that it's a 60 hertz, and so you have to know how long the U sleep is. If you're doing this properly outside of here in a const, you would have put 1/60 as a const, or 60 hertz in terms of milliseconds. So 1/60 times a million, or 100,000. Yeah. So you'd do it the other way, right? You'd actually say what it was. But that's the game ticks. Are perfectly reasonable. The physics update per object, you say, well, actually, maybe we should make that an actual physics container will do that. We'll hand it off to them rather than doing it inline in the frame. And so we can, because at the moment, this update happens before you render. And so because of the way this code is structured, you do all of that physics update, and then you'll render a frame. So what you might say, well, if I had multiple CPUs and I'm running my GPU separately, I don't want my rendering necessarily to wait until all of the multi-threaded CPUs are finished. What I'll do is I'll set my physics update running on all the CPUs, and I will snapshot into a system state which the GPUs can render. And so I disconnect my physics update from my rendering update. That, however, requires you to be thinking of a modern machine that was completely multi-threaded, rather than a very much of a one-threaded machine that will do the physics update and then the render and then the physics update and then the render. It's saying, well, okay, those two things are only shared through game state. What we'll do is we'll do all the physics update on the game state constantly, and we'll render at a fixed rate. Right? So those two things you can actually separate out. But most of this was designed before they had multi-threading, and so you wouldn't expect it to be designed with multi-threading in mind. Right, curious, what do I consider awful? Can you show us the code you wrote when I Yeah, there's lots of that was awful. Okay, so if I go open project, and I go get, and I go thesis code. Yes, I'll save that. Okay, so vector list, yep, source one, that's fine. Okay, so here this is code that I wrote, as you see, Simon McCallum. This actually, at that stage, I was. So actually, that was updated more recently. So that was 2003. So this is, only 17 years ago when I did my most recent update, because I was doing parameter stuff for it. I don't know if any of my other things I've got older. No, the 2003 was when I was kind of doing some of the actually putting the header statements and things. As you can see, some of the files just don't have them. Some of the files have them. I wasn't very consistent. I didn't spell things correctly. Yeah, my random number generator, because I was writing my own code. This, I had a big explanation of where it came from, because I read it from a research paper and re-implemented it from the code they had into my code, and so this is ugly. I have no idea how this code works. Apparently it generates a good random number generator with a whole bunch of magic numbers in it, and this apparently generates a uniform number with a cyclic cipher, right? With a twisted cipher. So it is yeah. The research paper, I copied it in from the research paper. I ran it. I tested to see that it did what it was supposed to do. Ugly code. I can't touch it. I can't update this. I don't understand it, right? So to some extent, for me, this is ugly code. It works, but it's ugly. I don't feel happy that I would be able to make logical changes to those bits of code in here, where it's shifting and initializing and spinning and doing crazy shit, but like from 0 to 97 and from 0 to 24, setting a whole bunch of random values and multiplying and modding them and multiplying and modding them and adding the remainders and right, yeah, ugly as, right? I don't need to understand how it works, so long as it always generates good random numbers that are statistically random, it's fine. Okay, so that's some ugly code I didn't that I used in my thesis. I didn't write. If we want to look at some code that I created, so there's a debate over whether or not this is acceptable or not. One of the things I've done here, this was C code. I wasn't doing C++. This is long enough ago that I wasn't doing that. Now, actually, when I mouse over, I actually have tooltips because it recognizes my comment. A smaller way to write for loops. Basically, what I did is, because I was writing so many for loops, I wrote a macro in my utilities function, my utilities file, which took the word for and a number and another number, and then just expanded it out to a for loop. Goes like the number 2 goes from 0 to n. Right? It was just because I was always moving from 0 to n, so it was the value. So I then have a net weight of 2 and from, and I'm going to go from 0 up to n, and the second one is going from net to there. Now, should I do this or should I have the long form? It's a coding style. I picked one. I'm not sure I'm happy with it. Yes. I still don't see the tooltips here. Sorry, you don't see the tooltips, but there are tooltips on it because it was a macro. But so here you should be able to see that for loop looks not very much like C++ code, but trust me, it's C++ code just with a macro that does things. For me, that's a reasonably obvious stepping through, setting everything to 0. Init weights, I should have gone the long form and said initialize weights. That would have been better. And here return 2 is basically, again, old style programming. Why am I returning an int? Well, I'm returning the number of nodes that I went through. This will return n to say that it went through n nodes. Why? Well, I thought it was clever at the time. It wasn't clever at the time. It was unnecessary. I never used the return value from initialized weights. I should never have had a return value. It was just me being stupid. So sorry, yes, that's just, yeah, crazy, stupid. Don't do that. So again, if it's only gonna change the values in there, you make this void because it doesn't need to return anything, and you'd get rid of the return. Right, so that would be a simple refactor to say, look, I'm not expecting it to ever return a value. I shouldn't. There's no test case to see that it does anything else. There is no way for it to do anything else. That was me kind of saying, hey, maybe I want to know how many things were set. Well, I know how many things were set because it's the static net, and net n is what I passed in. So I know how many things got set. This was just me being a dick. Right, so that would be one thing you'd do. Decay weights, again, I did the same thing with returning 2 because I copied the function and didn't think, oh, maybe this is actually a void function because it doesn't return a value. So yeah, so that would I change. So adding to value. So again, a nasty big ass switch statement. At least here I use a case and a enum, right? So these were the types of weight capping, but here you start seeing like, oh my god, what? Why am I dereferencing weight and then adding value to it with a plus equals? And then if the weight's greater than the capping value, set it to the capping value. If it's less than the negative, set it to the negative cap. That's a hard cap. A soft cap is that I use some sort of weighted approach that if it gets too big, instead of just capping it, I let it get too big, but I scale the amount that it can expand to try and stop it getting too big. So this was basically soft cap and hard cap. I was trying different things, but that is because this is a pointer to a double, and so what I'm doing is I've passed in a pointer to the thing that I want to change, and so instead of return, and I do return weight at the end here, right? I return whatever it is pointing to, right? This is ugly, ugly, ugly code. It is just me going there, hey, cool, I know how to dereference a pointer. Because I know how to dereference a pointer, you can pass a pointer and I can dereference it. Haha, I don't need to make a local copy of it. And it's kind of, why? Why would I even think that was the right way of doing this? Right? It is bad code. I should get rid of that. I should say, okay, you can pass in the weight, but I will return it and I will not do any of this incremental changing of it on the way in, changing it in position and then returning it. Returning, like changing the weight during the function and also returning it. I know that was a Unix way of doing stuff. It is a stupid way of doing things, right? So please don't ever do that shit yourself. I know I did it. I'm not proud of that. I would not do it again. Yes, there is lots of stuff going on here. Right, so this is me doing a code review. So as I said, and if you guys are struggling to follow how that code works, exactly, that's why you need code review. If I was writing this with the thought that other people were going to read it, because this is my thesis, I was working alone. I didn't think, other people will have to work with this code. I would be writing it differently, and it would be easier for you to understand. Okay, so this is the sort of stuff. You not understanding my code is what happens to other people when they read your code if you do not think other people will read your code. And so yeah, so some of this is really, that was really bad. Lots and lots of for loops. It's a big thesis. Do I have any really nice code that I could show you from my from doing this? Some of my you know, here I'm doing an if pattern file is none, then, you know, if not valid file, then, you know, it actually gives you the printf, please write the input file. It then flushes the standard out. It then grabs the file name. So, you know, I do some nice things that if you're trying to load files and you don't, it actually will do an interactive thing. So, you know, that's a nice catch for if I was putting in the wrong file. So I do try to give reasonable error messages. I spell things incorrectly, but yeah. So I mean, there's some code here isn't too bad. I'm not particularly fond of this sort of thing though. Yeah, that's an ugly way to say if you're at the end of the row, right? You've done the number of columns. It uses a mod, the number of columns on the column I'm in, and if you compare that to the same as the number of columns that there are -1, so I'm in the last column, then it will print at the end of line, right? Ugly, hacky, lots of technical debt there. So yes, unfortunately, some of that's not particularly nice. Now I can, if I find, and I'll try and find it for you. Is it in here? I've got a nasty feeling that I do some truly terrible stuff in relax. Where is param random general net sampling? Is it under sampling? Check against patterns. Yeah, no, there's going to be some. Yeah, I've got some fairly nasty things that I do in my code, and you can see, yeah, things like that line there, where I have a bunch of 0.5s and I have a success rate, but I don't, you know, 4 magic number. What the 4's doing there? So no, coming into this code, there are lots of stuff about this code that is bad code, and I would not do this if I was working with someone else. I even do some terrible things where I multiply by the result of an if comparison. To show you a better version of that, and I'll actually go and I'll open the other project because I can't really. Oh, actually, if I can go to open recent file, open recent projects, and I'll go to that one. Yeah. Okay, so one of the things you can do, and again, you shouldn't do this sort of thing, but so if I'm going to set a as an integer, what if I set a is set to 1 is greater than 0? What does 1 greater than 0 return? Or, you know, 1 equals equivalent to, oh, I'll make that equivalent to 1. That's an if check. So that should return 1. So I could multiply that by 5. And now I'm able to, instead of doing if check, I'm able to do a Boolean operator, right? So I can do the check of a comparison and then multiply that by a value, which means I'm kind of saying, you know, I could say if a equals B, multiply it by 5. So now this would, A would either be 0 or 5, right? So it's a weird way of using a boolean as knowing that a boolean is a 0 if it's false and a 1 if it's true, and then multiplying that by a value, right? That is stupid and ugly, and again, you shouldn't do it. I do that in some of my code. It's fast, but it's broken, so don't do that sort of thing. That's very bad code. Right, and it's getting close to the end of the time when I'm allowed to talk to you. So the last thing we can do is I can also have just a quick look at recent projects, and think, where did I put it? Oh, recent files. Nope, not that. Not that. I thought I had. Yes, this code. Okay. So, some of you may have seen this code. It's example 12 from the algorithms course. Now, max node constant integers all good. Two-dimensional array, perfectly reasonable. Normally, you wouldn't have such a long comment around that. Also, you wouldn't use the word A. You'd actually say what this array was about. And here it's an adjacency array, apparently. And now I'm going to go through every node and set it to 1. But this is badly laid out, particularly with these immediately following, because that should be like that, to say, well, that's actually a for loop. It's going to go through everything. And of course, as we all know, for loops in C and C++ never ever start at 1. They always start at 0. So that is not a style issue. That is an actually correct and incorrect issue. So you never go to 1 to max node. No, you go from 0. Just that's not style. That's just correct or incorrect. This is possible to do, but an incredibly ugly way of doing that. Yeah, no, that's just not very pretty at all. Works. I don't like these sort of multiple sets in a row with a number. It's just hard to read, and it's not particularly pleasant. It works. Now, of course, you have initializers, so you can actually initialize an array like this and initialize two-dimensional arrays. So you would never code it like that anymore, right? So you'd actually write it in the initializer for the arrays. So here, oh yeah, I mean we're going from to, and yeah, no, that's reasonable. Whereas that, so you haven't reached the end, so, and you're going to step through, then you do a for loop, stepping through each of the unseen ones, and you visit them. So this is recording this is the sort of recursive visit call that you get when you're doing a node span, and that's perfectly reasonable. Yeah, I mean, it's not 0 and the value is unseen, then that's fine. Again, I'd like to see extra brackets put around these to make sure that you actually know where the scope of each of these functions are. So in our world, we'd do that, and again, you'd move that down and have it in its own function, have it in its own scope. Yeah, C and C outs like that are acceptable. Yeah. Having big white space in the middle of lines is generally a bad idea. It shortens your lines of code, but you can have C in and C out like that, and that's perfectly acceptable for a C in, C out pair, C in, C out, C in pair, right? So you can see that way what's going on. You don't have to kind of read it off to the end there, and you kind of block them like that as a pair, and if the from node is less than 1, or the from node is greater than max node, or the till node is less than 1, or the till node is greater than the do node. Yeah, so while any one of those things is true, keep going. Okay. Yeah, no, that's reasonable. So yeah, so I mean, there's not too much wrong with that code. Some of the commenting's a bit much, but that's because it's educational code. You'd never set your code like that. So yeah, there's some bits of that that are that you wouldn't do. Okay, so yes, there are more confusing ways. Magic numbers, yes. Confused screaming, yes, lots of confused screaming, and right, so apparently there's a meme of Rhoda in the thing doing like disliking some bits of code and liking other bits of code. Okay, so yes, I can open the original and actually see that. But yeah, so no, there are if you were to go through and yes, I see create edge versus a I think a create edge function rather than a massive block of setting them to 1 would be a better way of doing it. From the people in Discord have suggested that for some of this code there, instead of using this block of code, you would actually use a function that would create edges, and then you could just give it a list. There are other ways of doing that also when you construct an array. So yeah, but so going through the code, I'd say it's okay. Redo your initialization, and tidy up some of this so that it's so this should be tidied up here. Refactoring it kind of does what it's supposed to do, though I think if you give it numbers that are too large, I think it might crash. But yeah, so no, and that's kind of a bit of looking at some of that code. Now, for next week, seeing you guys are now, I've helped one of you with setting up your a YAML file, a continuous integration a CD YAML file. Hopefully you guys are starting to actually implement some of these Git repos, the Git repo stuff, and starting to use smart commits. So how many of you are using smart commits? And that's using where you use the hash and an issue number to attach to your commits to your repos. And if you're not, you should start using those. You should also start issue tracking. I would like to review some. I'd like to start seeing some of the code. Some of you will already have code that you've been working on. It might be nice to review some of that early. And so if we can get during the week, I'd like someone to volunteer to have their code reviewed. I will be nice to your code. I won't say mean things about it, but I will try and help you improve it and discuss it. Excellent. We've had a volunteer. Some of you are using smart commits. That's wonderful. If Young Gunners group, if you can and do a code review, we'll bring up your code and we'll go through that code and we'll start discussing it. So you'll need to get a microphone for next week so that we can have that discussion. I would also do code review for probably about an hour, and then we'll have another discussion. Yeah, good. I'll also like to have another discussion on one of the other topics. Ethics is a bit larger. I'll move that to later in the course. But what I could potentially is we'll do an hour of code review with Young Gunners group, and then what we'll do is I will talk about some of the group collaboration tools that you can use, right? And some of those decision-making stuff that we do to try and make groups work well. Now, the other question is, are any of you going to the Global Game Jam on the 31st? I think it's 31st and 1st and 2nd. So I'm helping host a site here in Dunedin for the Global Game Jam. So I'll be in and out during that weekend. And so yeah, so I'd be interested in any of you going to that. Therefore, I can kind of see if you are game jamming. It might not be the best time to game jam unless you can kind of think, hey, we're gonna. Oh, you forgot to buy tickets in time. Yeah, the Hummer one is pretty full. So so we've another group here who's in the planning stage. Yes, and who are likely to book in a discussion. So, so there's 5 people who are the same. Who you can join just yourself in your own kind of in Yuvik, but it is more fun to be at the big event with lots of people. So yeah, no, if we can get Jon Gunnar, if you could send me a link to your repo, then I can kind of do a little bit of look beforehand as well, which will help me kind of do a better review. And we'll have you for an hour, and we'll talk about group cohesion for the second half of that hour, because we don't want to do a 2-hour code review. That would be too much for the recommendations. Okay. So I'll put the vector code that I have there, which is kind of middle of the road up, so you guys can have a look at it if you're interested. My thesis code is publicly available, but it's really horrendous and impossible to follow, so I wouldn't even try. I know it works, it just isn't pretty. And if there is any other code out there that code you find online, think, ooh, is that good or bad? And post it here, and we can have a wee chat in the Professional Programming Discord channel. If there's code that you'd like someone to give comment on, we could push it here, and we can comment during the week. But we'll do those code reviews. Okay. So, Jon Gunnar, you're going to discuss your commit standards and your smart commits. Okay, we won't code review your code. If there is someone who wants us to have a look at what you've got so far, if any of you are building on a project you did in 360 previous semester, then yes, we can have a look at some of that code. But send me an email. Right, so we've got some trading going on. Okay, well, with that, I will say good night to you all. Hopefully the audio was a little bit clearer this time than last time. Yes, we'll get on to doing some code review of your code and discussing smart commits and group collaboration next week. If you have any questions, email me or ping me on the Discord. Not always as reliable on the Discord as I might be on email. So good luck. I was pretty impressed that I was able to debug a continuous integration GitLab issue at 11:30 at night, just as I was lying in bed, and I got a Discord beep, and I had a look, and I did the remote tech support, and it worked. So I was quite proud of that. So yeah, have a good day, and good luck with your bachelor thesis projects. Okay. No.